Hi, everybody. Welcome to today's webinar presentation. We're just going to give another 1 or 2 minutes for a few more people to join. All right. Good afternoon, everybody. Welcome to today's webinar presented by the Canadian Water Resources Association. Before we get started, I'd just like to point out a few things in order to make sure everything runs smoothly. The presentation should run for approximately 40 minutes, and anytime during the presentation, you can feel free to type any comments or questions you may have in the questions panel in the GoToWebinar control panel. I've typed a short welcome message to get you started. All questions will be held and asked on your behalf at the end of the presentation, and a PDF file of today's slides will be distributed in a follow-up email in the coming days. As always, we appreciate your feedback. Our presenter today is Dr. Annemieke Farenhorst, and she is a professor in the Department of Soil Science, University of Manitoba, and the Prairie Ensert Chair for Women in Science and Engineering. Her research program focuses on pesticides, natural steroid estrogens, and antibiotics in soil and water, and on community engagement in water resource management. Dr. Farenhorst is the principal investigator of the H2O Create H2O program for First Nations water and sanitation security. She has earned a range of teaching, research, and outreach awards, including the Queen Elizabeth II Diamond Jubilee Medal for Leadership in Pesticide Research, and the Dr. and Mrs. Ralph Campbell Award for her youth outreach work and mentoring women in science. Dr. Farenhorst is the Canadian representative on the Division 6 Chemistry and the Environment Committee of the International Union of Pure and Applied Chemistry, and as an associate editor for the Journal of Environmental Science and Health, Part B, Pesticides, Food Contaminants, and Agricultural Wastes. And with that, I'd like to welcome Dr. Farenhorst and hand the presentation over to her at this time.
Thank you very much, Jody. It's a pleasure to give this seminar, and I would like to thank the CWRA for hosting this. I would like to talk today about safe drinking water rights, and particularly looking at some of the research that we have done and are doing in collaboration with First Nations communities in Manitoba. Thank you all for being part of this webinar. I really appreciate it. So this is a picture that was taken quite some time ago. This is me as a baby. And as you can see, I very much enjoyed sitting in the top of water. And when we're thinking about water, water is very important to us. Water, we grow in water, and when a mother gives birth, water is very important to that. This is a quote from a website from the Assembly of First Nations, and that says, "Water is the giver of all life, and without clean water, all life will perish." I think this is a very important statement and something that is true. So we are very much interested in water. If you look at the popular literature or the scientific literature, there's a lot of discussion about water. We look at whether or not we have enough water and who access that water. We have socioeconomic factors that compete for water that we have on this planet. And we have large discussions about what kind of management can we put into place in order to protect our water. When we're thinking about our drive to explore other planets, one of the first things we wonder about is whether there's water on those planets, because water may mean that there are life forms on that planet. And also we're thinking about if we ever would go to Mars, for example, something that is essential for us would be water to survive. So when we think about water that is present on the Earth, there is an estimate. If we're thinking about the water that is in our atmosphere, in our lithosphere, water that might be tied up in ice and snow, we can make an estimate. And as you can see on the number on the screen, there are a vast number of liters of waters on our planet. And when we're thinking about that massive amount of water, most of this water is actually not suitable for human consumption. So if you look at this water droplet, and the water droplet is very large in terms of the total water that's available to us in terms of on our Earth. But if we're looking at what of that water is actually safe for consumption, it's only 1% of the water that's present on Earth. So when we're thinking about that, the water that we have, that we can't consume, it's very important for us to protect that water. When we're thinking about water, this is a hierarchy of needs that was developed by Maslow quite some time ago, but it's something that is often used to express human beings and their capabilities in life. If you look at the basic needs, water is a basic need, just as breathing, food, and sleep. And if we don't have access to clean water, we cannot reach the other fulfillments that we are looking for in life, including safety and security, love and belonging, and so forth. So water is something that is very, very essential to us. And so for that reason, if you're looking at the United Nations, there is a resolution which is that it's a human right to have access to safe drinking water. And this is a very important statement because there are still large regions in the world where humans do not have access to safe drinking water. And if we're looking at our own country, Canada, we also have communities that do not have access to safe drinking water. So when we're thinking about safety of water, how do we actually know water is safe? Well, if we're looking at regulations, we actually define when water may not be safe. And to give you an example, much of my research is looking at pesticides, and I'm originally from the Netherlands in Europe. So I'm quite familiar with European regulations as well as Canadian regulations. The number you see here, the 0.1 microgram per liter, is the drinking water quality guidelines for a pesticide in the European Union. So the drinking water quality guidelines that are being used in the European Union indicates that for any given pesticide, you cannot have more than 0.1 microgram per liter in your water. Because if it exceeds that limit, the water is no longer safe for consumption. Of course, this is a very small number. 0.1 microgram per liter translates to a drop of a pesticide in about 500,000 liters of water. Now, if we're looking at the Canadian situation, in Canada we have a different approach through two regulations, and some may say that we have a much more relaxed approach. These are some of the examples that we use in Canada for our Canadian drinking water standards. So for a herbicide such as glyphosate that is widely used, the maximum drinking water quality guideline is 280 microgram per liter. For 2,4-D, it's 100 microgram per liter, and for bromoxynil, it's 5 microgram per liter. Very, very different from the 0.1 microgram per liter standard that is being used in the European Union. So if I look at some of our research then, this is looking at pesticides in groundwater in Alberta. The numbers that you can see here are the maximum concentrations that we detected over a 2-year of study for a range of pesticides. So if we would be in Europe, all of these detections would be in violation, meaning that this well water should not be consumed, because for each of the pesticides, the 0.1 microgram per liter is exceeded. However, if we're looking at the Canadian drinking water quality guidelines, none of these pesticides exceed our drinking water quality guidelines. And some of the pesticides do not have guidelines at all. So depending on where you are in the world, the evaluation of contamination may be very different, including whether or not that water is safe to drink. Now, the reason for the differences in these regulations between Europe and Canada is because we have a different assessment in determining what is safe. Europe is taking a precaution approach, and that indicates that if we can detect it with the current technology, and most of the pesticides we can detect at a level of 0.1 microgram per liter, if we can detect it, then that means that the water is potentially not safe for consumption. If we're looking at the Canadian approach, we look at an approach that is more based on toxicological endpoints. And so we're looking at the impact of a pesticide on organisms in the laboratory, for example, rats or mice, and then we translate that, what this toxicity may mean to humans. So as a result, the regulatory system, when we're thinking about pesticide concentrations in water, is very different in Europe than it is in Canada. So when we're thinking about regulations and the safety of drinking water, we know that chemical contamination must be kept at acceptable levels. And acceptable levels is defined by the government in the country in which you are located. When we're looking at microbial pathogens, some of bacteria are pathogenic and can do harm to us. If we're looking at those factors, countries are much more in harmony, and we all understand that water must be free of microbial pathogens at all time in order to be safe for consumption. So when we are looking at the Canadian guidelines then, in terms of the drinking water quality for microbial contaminants, E. coli should be at the level of 0 coliforming units per 100 ml. And that should hold for water leaving a water treatment plant. It should hold for water that is distributed from the water treatment plant to the homes by pipes. It should be true for water that may be stored in a cistern, in a water holding tank, and then is connected to a tap in the home. And it should also be true for groundwater that we use, well water, for our drinking. So the microbial quality guidelines indicate that E. coli should not be present in our water distribution system. We can also measure other bacteria, total coliforms. E. coli are part of the total coliforms, and total coliforms include a host of other bacteria. If we're looking at these guidelines, we also want it to be 0 CFU per 100 ml for the water leaving the water treatment plant. And if we do detect total coliforms in our distribution system, it indicates that we have problems, which could include that we have biofilm formation in our pipes or water holding tanks. And as a consequence, bacteria move in our drinking water. Or it could also mean that maybe our pipes have leaks and we get the intrusion of groundwater into our pipe system and hence bacteria. So when we do detect total coliforms, a retesting or investigation is required to see what the problem is and how it can be fixed. So living in Winnipeg, there was quite a scare last year in January 2015, and there was a 3-day boil water advisory issued. And so there was a suspected case of bacteria in the drinking water. And so there was a lot of discussion on this. Whenever you listen to the radio, it was about this issue. People were, some people were almost panicking and very concerned. And there was a follow-up, and this involved a 1,000-page report. And that was a full investigation of how samples may have become contaminated. And the conclusion was that the samples, it was probably false positive, so the system was never contaminated in the first place. But it certainly made people well aware of what may happen if the water system is contaminated and what kind of impact that can have on our daily lives. Now, in the meantime, Winnipeg, their drinking water is coming from Shore Lake. So this has been going on for quite some time, since the 1900s and early 1900s. And so we get our drinking water from Shore Lake. And at Shore Lake, there is a First Nations community, which is called Shore Lake number 40. And this community does not have a water treatment plant. It also is not connected by a road, and it's quite isolated. I was at a presentation just yesterday where there were members from Shore Lake number 40 and presented on the history of this whole issue in terms of Winnipeg getting their water from Shore Lake, but Shore Lake itself not being able to have a running tap with clean water for already 17 years. So when we're thinking about this situation, we know that there are First Nations communities that provide or help to provide water to a city such as Winnipeg. But the First Nation community itself cannot enjoy clean drinking water. Shore Lake is not the only First Nation in Canada that is under a boil water advisory. When we're looking at the number of First Nations that are under a drinking water advisory, which mostly is because of a boil water advisory in concerns about bacteria, at any given time there are about 110 First Nations communities under a drinking water advisory. Across Canada, we have about 600 First Nations communities. So if we're thinking about the number 110 communities that are affected by drinking water advisory, it's proportionally a very large number of the First Nations communities across Canada. There has been a lack of progress in dealing with the situation. These are some numbers I check from time to time on the number of communities that are affected by DWAs. And you can see that since 2009, there has been virtually no progress on improving the situation. There are some older studies available, and these also show similar numbers about the situation. And there are also some studies that have been done about looking at the duration of these drinking water advisories. And the longest duration, we're looking at 14 years, 17 years in the case of Shore Lake. So these are long, long times. The average duration of being under a drinking water advisory, the number in one study was 1 year. So these are being under a drinking advisory for a long, long time. And this does impact people in a way that they can do things, including reaching education and having social economic development in the communities. So we have been looking at drinking water quality in some First Nations communities, and this is done through collaborations, and we are very grateful for these collaborations. And I think our results are important to look at the issue and to think about solutions. So typically in First Nations communities that do have a water treatment plant, parts of the homes are served by pipes. So there are pipes that connect the water treatment plant with homes. But there are also homes that are not connected by pipes, and they rely on water holding tanks that we call cisterns. And cisterns can be either above ground or they can be below ground. We typically find that the below ground cisterns are the worst. Many of them are made from cement, and the cement is cracked, and this allows groundwater to seep into the cistern. So above ground cisterns are definitely preferred over the below ground cisterns. And the status quo when we're looking at new houses and new developments is typically now above ground cisterns. Unfortunately, the status quo is also that a new home is more likely to get a cistern rather than being connected to the water treatment plant. And we do find that cistern water is not nearly as safe as piped water. So when we are looking at the numbers, about 50% of the homes have piped water. If we're looking at First Nations, 30% have cisterns, and the remaining percentages rely on, for example, wells, or do not have a running water in a home. So we can look at techniques such as DNA and RNA, which is quite sensitive techniques, and we have done some studies on this. The difference between DNA and RNA is that DNA can look at both dead and live cells, while RNA is exclusive to live cells. So if you apply both techniques, you usually get a wealth of information. And you can get information about which cells are live and which cells are dead, but both have given indication of the contamination of certain bacteria that may be present. And why that is useful is because depending on what bacteria are present, you can actually start seeing the source or potential sources of contamination. So that's why we like to use both DNA and RNA in our research. So I'm going to show some of the results, and I basically look at the phylum level, which is quite high up. So it's quite a broad classification, and later on in the presentation I refer to class and phylum. So this slide gives you an indication where we are in terms of generalization and groupings of the bacteria I'm talking about. So when we would take a sample from a water treatment plant, so a sample of treated water, we can use DNA and we can see a number of groups of bacteria that are in the water. So we have proteobacteria, plantomycetes, and cyanobacteria, and the latter two are associated with lakes, for example. So it's not a surprise that these bacteria are present. Now, if we look at the DNA results, we're looking at live and dead cells. So we can also apply only RNA. And when we do that, we see that the water sources is dominated by proteobacteria. And so we can conclude that the plantomycetes and cyanobacteria in the treated water from the water treatment plant are dead cells. The proteobacteria, however, are live cells. And so when we're looking at water sources, whether it's water treatment, treated water from the water treatment plant, or whether it's water that we sampled from taps in homes that have piped water or cisterns, we do note that the dominant group of bacteria, the dominant phyla, is proteobacteria in all of the samples that we take. So proteobacteria includes bacteria such as E. coli, and so we can also use methods that are much simpler, E. coli, and to determine E. coli and total coliform levels in drinking water. There are a number of methods that we can use in our laboratory, and some of those are similar to what is being used in commercial labs. We prefer the filtration method, which is indicated by SM9222, because this gives us actually a way to quantify the number of colonies that may be present in the water. And so we like to use this technique to enable to do the research. So this is an example then from the same community as we did DNA and RNA work. And so here we're looking at the E. coli and total coliforms in water, in 100 mL of water. So you can see that the blue is the source water, that's the lake water. You do see a vast number of E. coli and total coliforms. And when you measure the treated water in the plant, both numbers are 0, which is a very good sign, because it means that the water treatment plant is operating nicely, and we have clean water that is safe to drink. Now, when we do similar studies in other First Nations, these data are samples that were collected in 3 First Nations communities across 7 sampling dates in Manitoba. And so we know from those studies that not all communities have water treatment plants that are always functioning as they should. This is the maximum number of CFUs per 100 mL detected of E. coli and total coliforms in the water treatment plant. And you can see that the numbers are 3 and 3. And we also looked at the E. coli and total coliforms in the water delivery truck, which is the truck that transports the water from the water treatment plant to the cistern water holding tank. And so sometimes the trucks are contaminated, and when trucks are contaminated with bacteria, this contaminated water is then entered into the water holding tank. When we look at the percentage of positive samples, you can see here 29% for the E. coli and total coliforms in the treated water, and for the water truck it's 16 and 25%. So for it depends which community. For the water treatment plant, it was always in the same community, the same one community. And for the water delivery truck, we had positive samples in 2 of the 3 communities that we were working. So we can go further then and look at the number of bacteria detected in the drinking water samples taken in homes. So typically we sample 10 homes of cisterns and 10 homes that have piped water, and we do that at certain times of the year and in multiple communities. So here you're looking at the average numbers of E. coli and the average number of total coliforms that we found in 119 samples. You can see clearly that the cistern water is not as safe as piped water, in that the average number of E. coli in the cistern samples is 57. So this is a very significant number when you think that the drinking water quality guidelines indicate that this number should be 0. So we can also look at data that is owned by First Nations communities, and these data are a reflection of the samples that the water tester takes in the community, and then either analyzes it in the community or through commercial labs. And if you're looking at these data, this is from one First Nations community. I use this as an example. There's a total of 722 samples, and this looks at the percentage of samples that were positive for total coliforms. You can see here that in this community, also piped water is sometimes containing total coliforms at very significant amounts, but particularly the cisterns are a problem throughout the year. If you're looking at some of the months in the fall, more about 50% or higher is contaminated with total coliforms of the samples that are taken in those months. This is the percentage of E. coli in these same samples. You can see here that, again, the cisterns are more problematic compared to the pipes systems. If we're looking again at some of the months, month September, 20% of the samples that were taken were tested positively for E. coli. So again, this is concerning to us that that's happening in our own province. So we have data for all First Nations communities in Manitoba, and I just give this to you as another example that in some regions there are very strong concerns when it comes to the cisterns. So this compares the percentage of water samples in 2014 that contain bacteria. So total coliforms, we can look at the treated water in the water treatment plant, in the piped water. There are detections, but the detections are rare. However, if we're looking specifically at homes that have cisterns, the detections are relatively frequent. We're looking at 25%. 30%, 31%, and 73% of the samples taken in 2014 were tested positive for total coliforms in these island lake communities. So the island lake region is accessible by plane, so it's about 1.5 hours from Winnipeg, and the communities are also accessible by a winter road. When we're thinking about these communities and compare it to Winnipeg, the communities have a high population growth. So most of the population is, not most of the population, but a significant amount of the population is below 14 years of age. Around 40% of the people in the Island Lake region are below 14 years of age. And if you compare that to Winnipeg, we're looking at about 17% of the population being 14 years old, below 14 years of age. So when we're thinking about contaminated water, the children and the elderly are often the most vulnerable population. And so again, it's a general concern for everyone. But we should really think about the impact that this contaminated water is making on the children. So we have looked at reasons why this contamination exists, and one of the things why chlorine is added to water is that it will prevent regrowth of bacteria in the water distribution line. So one of the things we noted that if we're looking at the average concentrations of free residual chlorine in the water, the chlorine concentrations are very low in the cisterns. In fact, they are on average about half of the 0.2 microgram per liter that the World Health Organization recommends for preventing bacteria regrowth in the water distribution system. So we know that the chlorine concentrations are a problem in the cisterns. In the piped water, the chlorine concentrations are relatively low compared to what we would see in the city of Winnipeg, but they are on average higher than the recommended 0.2 microgram per liter of the World Health Organization. So we know that in cisterns, one of the concern is the low concentrations of chlorine, and hence that we get a more easier regrowth of the bacteria. We have asked ourselves why chlorine is so low in cisterns, and one of the reasons that was a possibility is that chlorine can react with organic matter, with dust that may be present in the cistern, and when it does react, it forms trihalomethanes, and trihalomethanes are some of them are nasty substances that are carcinogenic, and so we looked at trihalomethanes in cistern and piped water, and we actually found no differences between the two cisterns. Well, we did, however, observe that the chlorination byproducts were higher than the maximum acceptable total trihalomethane concentrations of 100 microgram per liter, and this maximum acceptable level is set by the Canadian government and is related to whether or not the water may be safe for consumption. So the trihalomethanes, we see that they're higher than would be acceptable, but they cannot explain the reasons why the cistern would have a very low chlorine concentration. So what we're thinking that may be also happening is that chlorine reacts with the cistern walls. That's another way by which chlorine dissipates, or maybe volatilizing from the cisterns, or when it's being transported from the truck into the cistern systems. And this is something that we are going to look at this summer by following basically on a daily basis the chlorine concentration in cistern systems in the participating First Nations community. Now, I also want to mention some of the research we have done in homes that do not have a tap that provides running water. So there are First Nations homes that do not have running water, and shamefully 40% of the First Nations homes without running water are located in our province of Manitoba. And so people would have to get water from the lake, or would have to get water from a community fountain and haul this water to their homes. Often this is done by buckets, or the water is stored in drums, and you can see here an example of such a drum in front of a home, a blue drum that contains water. So we took samples from these buckets and drums, and we looked at the number of bacteria that was present in the buckets of the homes, or in the blue drums that were situated in front of the homes. And so we found on average that there were more than 7,000 E. coli, coliform units per 100 ml of E. coli in the buckets, and more than 13,000 total coliforms. When you compare that to the number of bacteria that we found in the lake water, the buckets contained much more bacteria than the lake. So when we looked at RNA-based methods, and we looked at the type of bacteria that may be present in the buckets and how that compares to the piped and cisterns, we found the majority of the bacteria were proteobacteria. But we've also found bacteroidetes, and these bacteria are actually an indication of recent contamination involving humans, so that maybe by saliva, washing hands. And so it's clearly that these buckets are not very safe, because they easily can become contaminated by the people in the home. So we know it's a new government, and the budget was recently announced, and I was delighted with the positive news for First Nations communities across Canada. I know Justin Trudeau made an election promise and indicated that the water crisis, I do think it's a water crisis that is occurring in First Nations communities, will be a top priority. Because this has gone on for far too long, and so I'm optimistic to see some change and some investments that will make a difference. So the research that I've shown you is part of the Create program, I would encourage you to check out the Create program and the opportunities that it provides in terms of linking communities with students. We typically the way it works is that the First Nations community would approach us and is interested in working with us to look at a particular problem that they have with respect to the water, and that could be drinking water or it could be source water, and then we match a student to the community. And that's how the collaboration starts. So we have students that are working, for example, development of source water protection plans with the First Nation community. We have students that look at sediment issues, turbidity in source water. We have students looking at wastewater treatment and so forth. So the program is quite multidisciplinary. It has a host of professors and a wide range of students in the program that works on a diverse range of projects. We adhere to the philosophy that collaboration is about learning from each other. So the students do research, they present their research results to the communities, but it's also the other way around, that the community members participate in the research and show the results to the students. And it's something that I think creates synergistic effects in terms of research results and impacts. So we have had more than 50 trainees since 2013. 1/3 of the trainees are self-identified Indigenous, and we have about a 50-50 split of men and women in the program. We also like to connect with schools. So many of our university students actually do outreach activities in schools, and we find that also very important when we're thinking about training the next generation of scientists, and engage students, both elementary and high school students, in the importance of water science. It is important, I think, for to have Indigenous students in the program, because they could be the scientists of the future and work with their own communities. When I think about the youngsters in Manitoba, 1 in every 4 preschoolers are Indigenous, and I think it's very important to enrich our education system and to make it a place that Indigenous students will exceed and find projects that interest them. So I would like to thank you for listening to this presentation. The concluding slides is a thank you note to our sponsors that help us to do the work. Without them, it would be very difficult to do the research and the outreach that we are doing as part of the Create program. So I'm very grateful for their support. So thank you very much, and maybe there are some questions or some dialogue that we can have.
Thank you, Dr. Farenhorst. Lots of great information presented here today. For all of the people attending the event today, I ask that you take a moment and type any questions or comments you might have for her at this time. I'll give you a couple of moments for that. And as you're typing your questions in, I'll just let you know one of our next webinar events will be on Wednesday, May the 18th, and is presented by CWRA and the Canadian Society for Hydrological Sciences, and will feature Sean Maytott from the University of Waterloo. Details and info will be found in our weekly newsletter and on our Twitter feed. I have put a couple of links up in the chat window for your browsing. All right, our first question comes from Walter, and he asks, where can we get more information on the NSERC program and how Aboriginal communities in other provinces can get involved?
Yeah, thank you, Walter, for that question. I'm just going to see if I can go back to, back to that one slide. Yeah, so this is specifically about the CREATE program. This is a link to our website. So if you Google CREATE H2O, you're likely to see this link. So our website, it displays information about which professors are involved and which students are involved, and it discusses the projects in a very brief way of each of the students. It shows some pictures of a typical day in the field for a group of students. So it gives a flavor of who's involved and what the program is about. It also has a link to the H2O Create coordinator, and her name is Wendy Ross. And so it gives the email address of Wendy Ross, the fax number, and the phone number. You know, if you would like to have more information, please feel free to contact Wendy. You can also contact me by email, and you know, we can provide you with further information that you would like to know.
Thank you. Another question from Walter. How many days or weeks can a water supply sample be tested after removal from the source in the home?
Yeah, so it depends what you, that's a great question, and something that scientists often struggle with. So it depends on what you test for, and I'm saying struggle with because for bacteria, for example, you have to analyze it as soon as possible and definitely within 24 hours. So when we work with remote communities, it's quite an organization. So we worked in the Island Lake region, and so we collect samples, and then we have to put them on a plane, and we have to have another team of students that are in Winnipeg get the samples from the plane and immediately analyze it in the laboratory. So for some contaminants that you're looking at, bacteria, you have to be very quick in terms of the analysis. For other things, you know, I'm thinking like, well, most. So for example, for pesticides, you also want to ship it the same day. You can, if you look at pesticides in sediment, for example, you could freeze that sediment sample, and it keeps quite long. It may keep months, and then so there's not that urgent need of to analyze it immediately. So it depends a little bit on the contaminant, but generally, the sooner the better.
Great, thank you. Richard asks, is it realistic to expect that those communities on cisterns will get their own drinking water plants in the near future?
No, yeah, and you know, I mean, I think it's a matter of priority. So you know, I mean, I think we're thinking about putting people on Mars, you know, in the not too distant future, and you know, I think of the things that are involved in doing that, and you know, so you know, I do think it's realistic, but it's a matter of priorities. What are our priorities? In terms of the cisterns, I think the cistern system can work, but there has to be you know, enough support system available to make that work. So for example, you know, there may only be one water truck in the community, and so if you only have one water truck and you have many people on cisterns, it becomes very difficult to actually clean that truck on a regular basis. So one option that would already make a positive difference is having more water trucks in that community, and so the water trucks can be cleaned, and the system will improve. Same holds for the cistern. the budget for cistern cleaning is I think inadequate in many First Nations communities. So if there is a better system in terms of making sure that there is enough funding and human resources to clean the cisterns, I think that would go a long way as well. For example, capacity building within communities of people that are on a payroll and actually make sure that cisterns are cleaned. But there has to be the funding and the will from the Canadian government to help manage a system that actually would work for First Nations communities, and each First Nation community is different. So you would have to look at collaborations and identifying needs and what are the best investment in the communities, and often the communities themselves would know what these best investments are. Another example is that some of the communities have these cement underground cisterns that are cracked, and so I think we should immediately replace all those cracked underground cisterns with above ground cisterns, and that will already make a positive impact on the situation. So I think small things can be done and that have a large positive impact on the situation.
And so as a follow-up question, Richard asks, what is sustainable cisterns or treatment plants? Perhaps you answered that already?
Well, yeah. I think sustainable for me is, when I think about sustainable, it's a system that works for the group of people that rely on that system. And so when I think about sustainable, I think about can the system do what it must do or what it should do? And if the system is working the way it should, I would think the system is sustainable. So again, I think the question is really looking at the needs of First Nations communities and making sure that the needs are met. And I think it's a responsibility for all of us to improve a very dire situation that many First Nations are under and are living with on a day-to-day basis. And I do think that there is possibilities to improve the way that First Nations are currently living, and I do think that we can create a society that we all live to the fullest.
Megan asks, in your opinion, do you expect the promised improvements in water quality on First Nations reserves will mostly involve building above-ground cisterns or pipe systems? Can the problems with water trucks and cisterns be addressed? And how do these problems with cistern water compare to cistern water quality off-reserve?
Yeah, so those are interesting questions. I do think that, again, whether it's a water treatment plant or cistern system, I think it depends by First Nations community, by First Nation community. So communities are not all the same. So I think you have to look at it on a case-by-case basis and what would be the best option for the community. In terms of how it compares the cistern systems on reserve versus off reserve, that is a question that we are getting quite a bit since we are actually starting to present on our results. And so this summer, we are one of my students is going to conduct a project whereby we're looking at rural communities as well as First Nations communities, and we're going to do similar measurements in cisterns and also in well water, so we get a better understanding of how the quality of water compares on and off reserve. So I don't know the answer just yet. But that's something that hopefully, by the end of the summer, we have a much better idea of that.
Great. And so just another final follow-up question from Richard in terms of climate change. As climate change predicts ice roads existing for shorter periods of time, is trucking water in a long-term solution?
I think that's a very good point. I was yesterday at the presentation of Shore Lake 40, and they were showing pictures about the ice road. And people have died because they tried to get some supplies, and the ice road was not as safe as expected. And so, yeah, I mean, I think it's climate change in that respect is a challenge, and then you start to wonder, it's probably much more economical and ethical in terms of safety that the community has a system in place within the community that is functioning well and is providing water, rather than a community relying on hauling in water, which is a very, very expensive way of doing things. And in case of ice roads, it's also sometimes a dangerous thing to do.
Great, thank you. So I'd just like to thank you, Dr. Farenhorst, for giving us your time and for Create H2O for this great research. Thank you to everyone for attending, and to receive future event notices, just go to cwra.org and sign up for our newsletter. Thank you, everyone, and have a great day.
Thank you, Jody. Thank you, everyone.
Thank you.
Bye-bye.